different address modes that 68HC11 supports. Let's look at them one by one. So the first one is extended addressing, and the second one is direct addressing, and the third one is immediate addressing, and the fourth one is inherent addressing, and the fifth one is indexed addressing, and the sixth one is relative addressing. So this is basically the answer. Now let's go ahead and see some more about them. So here, extended addressing, you can also use the short form ext for it. And the second one is direct addressing. The short form for this one is dir. And the third one is immediate addressing. The short form is imm. And then inherent addressing, the short inh. And then indexed addressing, the short form idx. And the relative addressing, the short form rel. Okay, now let's look at each of them. So extended addressing uses 2 bytes operand address. Okay, so totally it's going to take 3 bytes, 1 for the opcode, 2 for the operands. Okay, ADH is the high order address byte, while ADL is the low order address byte. Require a minimum 3 bytes for a complete instruction. Here's the example, LDAA, and it is pointed to an address, because if you see no number sign, if you don't see that, that means this is referring the address. So load accumulator A with contents at memory address 2E17. And then the second addressing mode is direct addressing, use 1 byte operand. So totally it's going to take 2 bytes, because 1 for the opcode and the second for the operand. So 2 bytes, and then ADL is the low order address byte, ADS is the high set to 0. Requires minimum 2 bytes for a complete instruction. And this also pointed to the address, memory address. But if you look at the difference between this and this, okay, so why this one need 3 bytes, this one only need 2 bytes, is because if you look at this, here we are representing, like we have 4 hexadecimal numbers, right? This is memory address, but 4 hexadecimal. 1 byte is 8 bits, so each hexadecimal number represents 4 bits. So 2 hexadecimal is 8 bits, that's 1 byte, and then these two make it 2 bytes. But that's extended addressing. But if you go to the direct addressing, it's only 2 numbers, and that is 4 bits for each number, so that's 8 bits. So it's only required 1 byte for the operand. Opcode need 1 byte, so totally 2 bytes. Okay, so here it says load accumulator A with the contents at memory address 0050. And the third one is immediate addressing, load register with a value from program code, not data memory. And example given, LDAA number $24. So this is not different. This is not pointing an address, this is pointing a number, because if you see this sign in front, this means this is just a number. So load accumulator A with 24, that's what this represents, and this is in hexadecimal because of the $sign represents. And this is a 2 byte instruction. LDAA takes 2 bytes instruction. Okay, and LDD, this is load accumulator D with 1, 2, 3, 4, ACCA with 12, and ACCB with 33, 4, because accumulator D is a combination of accumulator A and the B. Accumulator A represents the first 2 digits, accumulator B represents the last 2 digits. That combination of both of them is the accumulator D. So you can see that is when you have accumulator D with the LDD, this means A is loaded with 12 and B is loaded with 34, and this is in hexadecimal. Okay, and then LDY, same thing. but this is index Y register, load Y index 4 bytes instruction requires pre-byte. And the reason this can be done like this because index Y register takes 16 bytes at a time, so you can load 4 numbers at the same time. But accumulator D also 16 bytes, 16 bits, that is like 4 bytes, but it's combination of two register, ACC, that's 8 bits, and then ACCB 8 bits. That's how it make it to 16 bits. But LDY alone, it's 16 bits. That's 4 byte. Okay, and that is basically the immediate addressing. And then we have inherent addressing. Instruction does not need additional information, requires minimum 1 byte for a complete instruction. Example, clear A, set accumulator A to 0. So it just needs the opcode, that's it. And then we have seen inherent addressing, and the index addressing use 1 byte for operand. Offset address, offset unsigned, is added to corresponding index register, require minimum 2 bytes for a complete instruction. Here an example, ADDA, and here this is pointed to memory address, and that's gonna be, this is an addition happening to the X register. So add the contents memory address 32 plus X with accumulator A. So 32 added to this, and contents at memory address 32. So it's adding the contents at memory at 32 with X with accumulator A. That's what this ADDA means. And it only requires an opcode and offset, so totally 2 bytes instruction. Okay, and we have the last one, that is relative addressing. Use 1 byte operand offset for the PC, and offset is added to the program counter. Generally branch condition is met. Require 2 bytes for the complete instruction, 1 for the opcode and 1 for the offset, so 2 bytes. And here's the example, C000 BRA C002, branch always to C002. Would be encoded as 2000. When the instruction is executed, the PC is C002. 00 is added to the PC to get C002, therefore it would branch to there. Okay, and that's basically it. So the answer for this question, what are the 6 different address modes, 6H11 supports, that's basically this one. Extended addressing, that's 1, and then direct addressing, that's 2, and then immediate addressing 3, and then inherent addressing, that's 4, and then index addressing, that's 5, and then relative addressing, that is 6. Those are the 6. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.